Okay, now we want to do a quick synopsis of power functions. Now your basic power function is y equals x to the p. More generally, y equals a times x to the p. And these can be translated, shifted, etc. And maybe talk about those sometime. But the main thing we want to see now is the way to characterize power functions in terms of what happens to y values when x values double. Okay, so if y2 equals x2 to the p and y1 equals x1 to the p, that is, y2 and y1 are values of y that correspond to values x2 and x1 for the power function y equals x to the p, and this could be for any power. Then what do we have? If you do y2 divided by y1, we've seen the algebra of this, and I'm not going to go through the details of this algebra. If you have questions on this, please let me know. I'll be glad to go through them. But we have x2 divided by x1, quantity to the p power. Okay, so if we just take y2 over y1 is x2 to the p over x1 to the p, and that equals x2 over x1 to the p. Now, if, in addition, x2 happens to be equal to 2 times x1, then it follows that y2 over y1 is, well, it's x2 over x1 to the p. x2 is 2 times x1, so this is 2x1 over x1 raised to the p. The x1's divide out, and you end up with just 2 to the p, so that y2 over y1 equals 2 to the p. Now, this is a characteristic of power functions. If you double x, then the y ratio that you get, the factor by which y changes, is 2 to the p. And I'm going to pause and add a little note here. Okay, what I've just written in is that 2 to the p is therefore the ratio of your y values. y2 over y1 is the ratio of y values. And that ratio of y values can also be called the factor by which y changes. So if p equals 1, for example, y2 over y1 would be 2. So that doubling x would double y. The ratio y values would be 2. The factor by which y changes is 2. That means that y2 is 2 times as big as y1. If p is equal to 2, well, we'll do that example down here. Okay, so, and we could say then that doubling x increases y by factor 2 to the p for any power function y equals x to the p. So, for example, if p equals 2, then what's that imply? It says that doubling x will increase y by factor 2 to the p, which is 2 to the 2, which is 4. Okay? In other words, if you double x, y fourples. There's your fourpling function. Okay? If p equals negative 1, negative exponent that we just talked about, if p equals negative 1, then, well, I've got quotes here in yellow and that quotes this. Doubling x doubles y by factor, that's repeated in here, 2 to the p, which is 2 to the negative 1. P is negative 1, 2 to the negative 1. What's 2 to the negative 1? It's 1 over 2 to the 1. 2 to the 1, of course, being 2, that's 1 over 2, or 1/2. So for p equals negative 1, the y factor is 1/2. When x doubles, you get half the y value. This is in this function, the p equals negative 1 function is x to the negative 1. X to the negative 1 is 1 over x to the 1, 1 over x. This is your y equals 1 over x function, your reciprocal function. Okay? Now, just a question here, and we talked about this in class, but what value of p, if p equals what, would we get 2 to the p equals 3? That is, what would the value of p be for the tripling graph? Okay, now I could give you any factor and you could get an equation like this. If it was quintupling, you'd have 2 to the p equals 5. That turns out to be an equation that we can't expect you to be able to solve right now. It requires the use of logarithms. If you know how to do that, okay. If you don't, you're going to learn. and it's not that difficult. And you don't worry about it now. You just know there's some value of p, and you can find it by trial and error. Narrow down your possible values of p. Find one that makes 2 to the p greater than 3. Find one that makes p 2 to the p less than 3. For example, if p is 2, 2 to the p is 4, which is greater than 3. If p is 1, 2 to the 1 is 2, which is less than 3. So p would have to be between 1 and 2 in order to make it 3. Now try 1.5. If 1.5 gives you something bigger than 3, then you know that your p would be between 0 and 1.5 and so forth. Okay. Now the other thing is that any power function is easy to construct using doubled x values and a constant y factor. Okay, if you want to construct the p equals 2 function, the y factor is going to be 2 squared is 4. So you're going to list a bunch of doubled x values. You're going to construct those along an axis. You start with some value, you double that, you double that, you double that. Or you start out here and go half, 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 half. As you go from right to left, if you get halves, that means if you go from left to right, you're doubling. So if we have a set of doubled x values on the axis, and everybody knows how that works and what that means, then you figure out what your y ratio is. If it's 4, then you're going to fourple your y values. You're going to quadruple them. You're going to start with some y value here near the origin and make a y value 4 times as great, then 4 times as great as that, and then way up there 4 times as great as that. And you then use those points on the axis to get points on your graph. You don't have to have numbers. What you're probably going to do in pre-calculus or algebra 2 when you start graphing functions is you're just going to plug values in for x and you're going to get values for y. That's great. That's fine. There's nothing wrong with doing that. But it doesn't give you a tremendous amount of insight into the properties of the graph. And these properties are the central thing. The properties of the function are the things that's central to the function. And this kind of property just gives you an expanded ability to think about the mathematics, to think about the functions, to think about and recognize patterns, which is why we've done it here. Okay, and I wanted you to get very good at these patterns. And most people got pretty good at constructing these graphs and doing some things with them, so I think you have learned things about these patterns. There's a lot more that could be learned, and I'll be doing a video on some of that. But this is a summary of the video we did on the last day, summary of what we went through on the last day. I also note that in calculus, you're going to get rules for calculating the slopes and the areas under a curve. Now, we've talked about slopes. We've talked about area under a curve. There are rules for that, and in calculus, those rules are actually pretty simple for power functions and for exponential functions. You know, we could talk about exponential functions, and we will. I do a kind of a summary video on exponential functions. Okay, so the goal here is to get a set of geometric properties, or basic geometric property of the graph of a power function, and to connect that with the formula for the power function.